In this demonstration we will show how to reconstruct diffusion-weighted spiral images with Skope-I. Skope-I provides a versatile framework to reconstruct MR images based on actual encoding dynamics. It consists of a set of compiled applications that can be run under Windows or Linux. Wrapping functions are available for MATLAB and Python to facilitate the usage of the Skope-I software package. In this demonstration, we will use the Skope-I wrapper for MATLAB to perform the reconstruction. The first step is to add the Skope-I scripts to the MATLAB path. Next, we define the in and output folders. The scanner folder contains the raw data acquired by the scanner, and the camera folder contains the trajectory raw data measured with the scope camera. Before beginning the reconstruction, we also define 3 output folders. These folders will contain the converted MR data, the merged data and the reconstructed images. We are going to use the generalized sense algorithm to reconstruct our spiral dataset. We first reconstruct the required B0 and coil sensitivity maps based on data from a multi-echo GRE scan, then go on to reconstruct the diffusion-weighted spiral images. To begin, we define the scanner and camera IDs of the mapping scan and convert the scanner data to the ISMRMRD format. Once the conversion is completed, the scanner data can be merged with the camera data. The merging process will first align the 2 data sets and then resample the trajectory information to match the scanner data. The contents of the merged MRD file can be inspected in the MRD viewer. The MR data and the trajectory information for each acquisition can be displayed by clicking on the corresponding row in the table. Now that we have merged the trajectory information with the acquired MR data, we can begin the reconstruction procedure. The reconstruction process is fully defined by a so-called reconstruction definition object. Skope-I will suggest a set of reconstruction parameters based on the MRD data header. However, the user may modify the return structure to customize their reconstruction. Here, we chose for example to only reconstruct contrasts 1 and 3 and to perform the reconstruction in a parallelized fashion. Now, we can run the reconstruction by calling reconstruct with the recon definition as an argument. The images will be stored in the recon folder together with the used reconstruction definition. The reconstructed images will serve as input for the field mapping process. Similar to the reconstruction definition, the map calculation definition defines the entire mapping procedure. The B0 maps are calculated based on 2 images with different echo times. In this example, we use spatial unwrapping to correct the created phase difference map. The creation of the sensitivity maps requires only one set of images. By default, the raw maps are smoothed and extended. If the visualization option is set to true in the map calculation definition, the B0 maps and masks for all slices are shown while only the central slice of the sensitivity maps is displayed for all channels. The generated maps will be stored in the Recon folder next to the GRE image data. Skope-I will be able to automatically find and use this data for subsequent reconstructions that require additional sensitivity and delta B0 field information. After successful generation of the field maps, we are now ready to reconstruct the undersampled diffusion-weighted spiral dataset. The conversion and merging procedure for the DWI dataset is identical to the one shown before. For this reconstruction, we tell Skope-I to perform the reconstruction based on a higher-order K-space encoding model. The incorporation of higher-order K-space terms is required to account for eddy currents generated by the strong diffusion gradients. Out of the 4 spiral interleaves, we only want to reconstruct the last one. We also activate the creation of combined images for each diffusion direction. Based on the MRD data header and the presence of the field maps, Skope-I automatically activates the static B0 field correction and the sense reconstruction. Now let's call reconstruct again with the modified reconstruction definition. The dataset that is currently being reconstructed consists of 12 slices, 1B = 0 scan and 3 diffusion directions. The reconstruction of the first set of images takes slightly longer because the field maps have to be interpolated to the geometry of the diffusion scan. The reconstruction progress can be monitored in the progress window. The reconstruction runs in parallel on 4 GPUs. Each one of them can reconstruct up to 2 images simultaneously. By default, the images are stored as DICOMs, PNGs and MATLAB files. Once all images have been reconstructed, the DICOMs are rescaled to a common value range and the combined images are created. Let's wait a moment for the reconstruction to finish. That's it. All images have been reconstructed. Let's have a look at them. Thank you for watching. If you have questions or would like to have more details on how to integrate Skope-I into your data processing workflow, please contact your friendly Skope person.